I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics, medicine, nature,
or
Space. Time.
the brain,
Life. The universe.
Hello, welcome to a special episode of The Naked Scientist with me, Georgia Mills.
And me, Connie Orbach. And for the next hour, we'll be investigating psychoactive substances, from the ancient origins of drug use.
It seems very likely that taking drugs was something we were doing before we were human.
To one man's battle with drug addiction.
It was like a hammer blow to realise I was actually physically addicted to morphine at that stage.
And we hear how one organisation is calling for a change in the way we police users.
The resistance to making this change is not a scientific one, it's a political one, because the reality we live in at the moment is that drugs policy, both in this country and across the world, is driven by politics rather than the science, and that is a situation we need to change.
The Naked Scientist podcast is powered by ukfast.co.uk.
100 years ago, the first UK drug laws came into play, and it was the beginning of a long battle against the use of mind-altering substances. A war now being fought all over the world.
The drugs debate is one that encompasses politics, morality, welfare, and everything in between. But today, as always, we'll be focusing on the science. So stick with us as we examine everything from how addiction takes hold of your brain to a new revolution in illegal drugs research.
First up, what actually is a drug? I asked drug researcher and presenter of the podcast Say Why to Drugs, Dr. Susie Gage, to take me through the basics.
The World Health Organization defines psychoactive substances as substances that affect mental processes, for example, cognition or affect. So they affect sort of your ability to think or your mood.
How about legal drugs? There's lots and lots of legal drugs, which I'm assuming must affect your brain, things with depression and anxiety. Where do they fit into all of this?
Well, there are plenty of legal drugs that are used recreationally. So tobacco, alcohol and caffeine, they're all psychoactive substances. They're all legal, although regulated to a certain extent. Perhaps not caffeine, but certainly alcohol and cigarettes. But they do have these psychoactive effects as well.
When we're talking about the difference between illegal and recreational drugs, it's based on policy and where a line falls.
Oh, in terms of the legality, yeah, it's partly evidence-based. There's a lot of it is to do with sort of the history of the substance in the particular countries. So, like, it's not as sort of simple as saying, well, these drugs are legal because of this and these drugs are illegal because of that. There's sort of the blurring of the boundaries makes it really quite a difficult thing to quantify.
And when thinking of harm or possible good as well, that's not necessarily as fine a line of these ones are legal and they will do you good, and these ones are illegal and they will do you harm.
Yeah, absolutely. I mean, the two substances that are the most harmful at a population level in the UK are most certainly tobacco and alcohol. And this may be because they're legal and they're much more widely used than some other recreational substances. But it could also be that, and it certainly seems like it might be, that they are particularly sort of dangerous.
So that's really surprising when we think about, I don't know, how I might come across drugs. I would just be like, well, I'm allowed that one. It can't be that bad for me.
Yeah, absolutely. It's very misleading for someone trying to make sort of informed choices about what they put into themselves.
Yeah. And when we talk about informed choices and what they put into themselves, how do some of these drugs, specifically the illegal recreational drugs, how are they working in the brain? Or are they all doing the same thing?
No, they're definitely not all doing the same thing. There are lots of different sort of types of recreational drugs. So some are stimulants and they'll sort of increase the sort of bodily function. So they'll raise heart rate, they'll raise blood pressure, they might speed up metabolism, that sort of thing. Some are depressants and so have the sort of opposite effect, or analgesics, sort of have a sort of pain-killing effect. Some are psychedelics and have a kind of perception altering effect. And so they all work on the brain in different ways. But for the most part, this is due to their impact on neurotransmitters in the brain, so the things that get messages between neurons. And there are various different neurotransmitters and neurotransmitter circuits in the brain. And so some drugs will affect some of them and some will affect others. Some will sort of augment the processes of neurotransmission. Some will inhibit the processes of neurotransmission. So they all have quite different effects, but ultimately they're all affecting, for the most part, these sort of neurotransmitters.
So these neurotransmitters act as messengers, carrying information from one brain cell or neuron to the next. And when they get there, they match up with their complementary receptor, a bit like pieces of a puzzle. But what's really interesting here is that drug molecules can hijack the system and pretend to be natural neurotransmitters. This works because many of them just happen to be the perfect shape to fit with specific receptors.
We have a system in the brain called the endocannabinoid system, and surprisingly enough, certain sort of molecules or substances in cannabis bind to the endocannabinoid system. Who'd have thought? Why we've developed this in our brains is maybe up for debate, but we've got nicotine receptors in our brain, opiates and that kind of thing. These are all systems that are in our brain already.
How certain drugs came to fit so perfectly with receptors in our brain is certainly a bit of a puzzle. We do produce natural molecules that also fit to these receptors, so some people have put it down to coincidence. But there are also theories that maybe something else was going on.
Well, it's certainly the case that humans have been using drugs for an extremely long time, or certainly the sort of historical evidence seems to back that up, as well as the kind of suggestion that our brains seem particularly able to respond to these kind of substances. And you can see sort of evolutionarily why it might be advantageous. Like if you are chewing on a leaf and it just helps you concentrate that little bit more, maybe you're more likely to have a successful hunt and you're more likely to eat that night.
That was Bristol University's Susie Gage. And Georgia, I find the idea that we could have evolved alongside drugs just so interesting.
Yeah, it's not something you'd really expect, but later on in the programme I'll be looking at how our relationship with drugs did first begin. But before that, we'll be investigating how some of the most infamous drugs work and what they actually do in your brain. First up, it's marijuana.
Weed, grass, pot, skunk, whatever you call it, cannabis is one of the most commonly used drugs in the world. It's made from the leaves and buds of the marijuana plant and is either smoked or baked into foods and consumed. Each bud and leaf of the marijuana plant is composed of hundreds of chemicals, but there are two important ones: tetrahydrocannabinol, or THC, and cannabidiol, or CBD. While CBD contributes to making the smoker feel relaxed, THC is to blame for its psychoactive effects, or high. Every time someone smokes or eats cannabis, THC seeps through the bloodstream to the brain and attaches to cannabinoid receptors. These cannabinoid receptors are part of the brain's makeup, and THC is very similar to a naturally occurring chemical called anandamide, which usually binds to these receptors. THC floods your brain in much higher concentrations than the naturally occurring anandamide and causes the neurons that make up your brain to fire continuously, upsetting the normal balance of your brain. So, how does a bit of excess firing cause the user to get stoned? Well, cannabinoid receptors are prolific things and found all over the brain. This means that THC can impact on lots of different functions, from memory and hunger to pain and forward planning, giving all those well-known effects like the munchies and lack of motivation. Crucially, cannabinoid receptors are also present on the brain's reward system, boosting dopamine and causing euphoria and relaxation. The activation of this reward system is thought to be the common factor in all drugs of abuse. Marijuana is not a totally harmless herb, but with THC there is no such thing as a fatal overdose. A study on monkeys reported that a person can gobble up to 70 grams of the drug, about 5,000 times more than is needed to get high, and still have no toxic effects. Still, if you wanted to eat your weight in weed-infused treats, you might experience fragmentary thought, lack of concentration, impaired memory, drowsiness, and anxiety. Not to mention dry mouth, red eyes, and increased appetite and heart rate. Long-term use has been linked to schizophrenia and memory loss, although a clear cause and effect link is yet to be found. While it's true that some cannabis-derived drugs have shown promise in treating anxiety, depression, post-traumatic stress disorder, epilepsy, and neuropathic pain, the overall effect of marijuana on brain chemistry isn't crystal clear, and much evidence is still awaiting confirmation in clinical trials.
Khalil Thurlaway there. And drugs like marijuana are by no means a new thing. They've been affecting our science, our health, and our culture for a very long time. So I wanted to find out a bit more about the history of our relationship with mind-altering substances.
In Xanadu did Kubla Khan a stately pleasure dome decree, where Alph the sacred river ran through caverns measureless to man, down to a sunless sea.
That was a section of a poem written by Samuel Taylor Coleridge while under the influence of opium. It's one of many pieces of literature or music which has involved psychoactive substances. Robert Louis Stevenson reportedly wrote Dr. Jekyll and Mr. Hyde while on a 6-day cocaine binge. And sci-fi author Philip K. Dick wrote loads of his books while on amphetamines. So when did our love affair with these substances begin?
It's hard to say when people first started taking drugs because it goes way back before recorded history.
That's Mike Jay, historian and writer, who agreed to take me back through the history of drug use.
It seems very likely that taking drugs was something we were doing before we were human. If you look at animals, there are lots of animals that take drugs. For medical reasons, they eat poisonous grasses to kill intestinal parasites, for example. But there are also lots of animals who seek out intoxicating drugs. Cats, for example, chewing catnip. Birds or elephants, which will go long distances to seek out fermented rotting fruit and eat it in large quantities and get drunk. And when you get closer to humans, apes and monkeys, for example, use all kinds of drugs in the wild. So it's highly likely, I think, that this was something that we were doing before we became human, and that would explain why pretty much every human culture throughout history and around the world has used intoxicating drugs in some form.
When did the first archaeological evidence for drug use start to appear?
There's archaeological evidence for the use of drugs going back thousands of years. In the Americas, for example, there are dried quids of chewed coca leaf containing cocaine, which seem to go back several thousand years, maybe 10,000 years. By about 4,000 years ago, you're starting to find artefacts like pipes made of hollowed out animal bones, which have residues of intoxicating plants and seeds in them. And in the old world, in Europe and Asia, the oldest evidence is for the use of opium heads and dried poppy heads. And then at the very beginning of writing, Egyptian papyri, medical papyri like the Ebers Papyrus, record the use of drugs. And then when you get to the classical era, Greek literature, people like Dioscorides write about plants and drugs and pharmacy in great detail.
What's clear is that people have been indulging for years, and for many different reasons. There's evidence people use drugs in spiritual and religious ceremonies, medically and, much like today, to help stay awake or for social situations. The first evidence of advising against drug use came from ancient Egypt in 2000 BC, when a priest wrote to his pupil, "I, thy superior, forbid thee to go to the taverns. Thou art degraded like beasts." But these kind of warnings haven't stopped drugs from spreading across the world.
The sort of global drug trade that we have now started really about 500 years ago, around the time of Columbus. If you go back before then, you'd find a world where in, say, Thailand or Malaysia, people are chewing betel nut, and in the Andes, they're chewing coca leaves, and in different parts of the world, people are taking different things. What you get from that point on, really the beginning of global trade, is around these kind of substances that we don't quite think of as drugs anymore, but things like tobacco and sugar and tea and coffee. The global network that emerged after the discovery of the Americas about 500 years ago, you start to see these kind of items being traded, particularly things like tobacco and sugar, really made up the first layer of what we now regard as sort of global trading routes.
During the 19th century, scientists started extracting pure forms of the chemicals from natural drugs. Coca leaf went to cocaine, opium became morphine. These drugs weren't seen as luxuries or bad habits, but medicine. It sounds bizarre, but you could go and get morphine from the local pharmacy. And cocaine was an ingredient in Coca-Cola until 1903. But slowly it did start to become clear that these drugs could do some serious damage.
People started to realise by the mid-19th century, when drugs were being used quite widely, that substances like opium were dangerous. It was very easy to overdose on them. It was the same time that people started to be concerned about alcohol and the health consequences of alcohol, which led to the temperance movement and eventually to alcohol prohibition. So from about the mid-19th century, you start to get initially regulations like the Pharmacy Act in Britain in 1868, which stipulated that certain poisonous substances, including opium, could only be sold by registered dealers and so on. So that was the way in which drug use was controlled until pretty much exactly 100 years ago, during the First World War, in the Defence of the Realm Act, was the first time in Britain that substances like morphine and cocaine were prohibited from open sale. And by that time you had, in the United States, the Harrison Act of 1914, which was an act that controlled the supply of narcotics. So the actual drugs as illegal banned substances, that story is about 100 years old now.
Thanks very much to author, curator and historian Mike Jay for that trip through history.
You're here with The Naked Scientists, with me, Connie Orbach, and Georgia Mills. And this week, we're exploring the science of psychoactive substances.
Later on, we'll be looking at how Portugal have reduced their health cost from drug abuse and hear about scientists who've started using ecstasy, completely legally.
But before that, let's head back to the brain and hear what actually happens when you take heroin.
Heroin, like morphine, is an opiate synthesized from the pods of the poppy plant. Although heroin's godfather thought that he was creating a safer form of morphine for pain relief, he accidentally synthesized an even riskier molecule and named it heroin for the feelings of heroism it instilled in the user. But within a few years, after being marketed and sold as a medicine for conditions like insomnia, heroin was found to be 2 to 3 times more potent than morphine and also way, way more addictive. Heroin, also known as horse, smack or junk, works in different ways. Part of it works as a stimulant, meaning that it speeds up your brain. But a greater portion is a sedative or depressant, which slows you down. Whether it's injected, smoked or snorted, it quickly enters the brain, where it's turned back into morphine and binds to proteins called opioid receptors. These are found in areas of the brain associated with pain, reward, and also in the brainstem, which regulates automatic processes like breathing. After docking onto the brain cells, heroin triggers the release of happy hormone dopamine, up to 10 times more than normal, which produces feelings of intense euphoria, relaxation, fearlessness, and tolerance to pain. Yet, heroin and other opioids don't suppress the pain itself. Rather, they change the subjective experience of the pain. This is why people receiving these drugs for pain relief may say they still feel the discomfort, but it doesn't bother them anymore. After more and more exposure to opioids like heroin, users begin to build up a tolerance to these flash floods of dopamine and need more and more of the drug to create the same effects. Heroin use can also cause pain systems to go into overdrive once the dose is worn off, meaning the drug is needed just to feel normal. Going without a fix can cause withdrawal symptoms like nausea, cramps, anxiety, fever, and diarrhea. Long term, heroin wastes the brain, causing damage to areas associated with memory, decision-making, and complex thought. One of the leading causes of death in users is to simply stop breathing due to the depressive qualities of the drug on the brainstem. In fact, according to a report from the European Monitoring Centre on Drugs and Drug Addiction, opiates, mainly heroin, were involved in 4 out of every 5 drug-related deaths in Europe.
Now, heroin is part of a group of drugs called opiates. These all act in a similar way and are all very, very addictive. Just a warning that the next interview contains graphic descriptions of drug abuse. So if you'd rather not hear that, then you can rejoin us in around 7 minutes.
Within seconds, I feel the rush coming on. Firstly, a tingle coming up my right arm. Then a wonderful warm tidal wave stroking my whole skin, my whole body. It seems to find a centre deep within my chest. I try to savour each moment, each instant, but just as quickly as it comes, it is gone. That's it, done, all over. It lasted a few breaths at most. I'm disappointed it's over and wish I could turn back time a few seconds. I also feel dissatisfied, a bit cheated. The rush wasn't quite as good as I hoped it would be. I wish I'd held off for a few hours. Then I'd still have the drug, and the rush would have been better. The drug makes me feel pleasantly languid, like I'm wrapped in cotton wool. But even at this stage, even so soon after injecting. Not much more than a few minutes, reality starts to pull me back in. The modest euphoria which lingers after the rush begins to leak away. I start to worry about getting rid of the evidence. Often I miss something. The syringe wrapping, a blood-stained tissue, the occasional needle. I am also becoming more aware that that was my last ampoule of cyclomorph. I already knew this, of course, but I had put off the evil day of facing up to it. Now there is nothing between me and drug withdrawal. I dread the next 48 hours. My name is Liam Farrell. I'm a retired family doctor and a writer. I'm from Rostrevor in County Down in Ireland. I am a morphine addict in recovery, and I've been clean for 8 years. And I have a very good life now because I was helped by some very good people when I really needed it.
Thank you so much for reading that, Liam. So that's an extract from a piece that you wrote about your own experience.
It's very hard to say how I first became addicted or how I first started using. I've asked myself that many times. But at some stage along the line, I decided to try morphine just to see what it'd be like. It's very hard to analyse why I actually made that step of doing that, but that's what happened. Initially, I would have used very infrequently, once every 3 to 4 months. But then at a certain stage, I began to use more. I remember very vividly one Sunday afternoon when I was on call, feeling really tired and exhausted and not really knowing why. And I took a small amount of diamorphine and suddenly I felt normal. It was like a hammer blow to realise I was actually physically addicted to morphine at that stage.
Can you explain to me, as best you can, what withdrawal is really like? I imagine it's kind of impossible to explain it to the intensity that you feel, which is why it's so hard for anyone to understand. But yeah, it'd be interesting to hear your take on it.
In a very essential physiological way, it's like your body is suddenly flooded with noradrenaline, the fight or flight hormone, but yet there's no reason for it. It's like all the other pleasant symptoms of taking morphine actually go into reverse. Instead of feeling languid and comfortable, you feel agitated and fearful. You're cold and freezing and sweating. You get diarrhea and abdominal cramps. None of those on their own are any more severe than bad influenza. But what is really debilitating is the fear and anxiety which is associated with it. That's a memory that will stick with me forever. Although theoretically I knew in a couple of days I'd be better, when you're in that state, rationale doesn't help. The catch-22, of course, is that even though withdrawal was so distressing, it didn't stop me relapsing yet again.
It's so interesting that, and I think so hard to understand exactly what you're saying, that this withdrawal can be so completely horrendous, and yet it's not enough. The drug is still in control.
Yeah, I mean, it's the power of the drug is just amazing. One of the golden rules of Narcotics Anonymous and Alcoholics Anonymous is that the drug will always win. I would hate to put my willpower to the test. I remember the particular colour of the cyclomorph drug that I used to use was blue and red, and it's such a key for me. If there was a pack of cyclomorph lying on the road half a mile away, I would probably pick it out. It's sorry.
That's all right. You've been clean now for 8 years, and it seems clean is never completely free. But what's it feel like now? What do you feel like this is part of your past?
Well, it's always going to be a pivotal part of my life that I am an addict. I wake up every morning and say, whatever happens, I'm going to stay clean today. And then when I go to bed at night, I say, well, whatever happened, I didn't use today. There's small elements of self-discipline which I'd forgotten when I had a relapse in 2008. At the same time, it doesn't define me. I have many other parts of my personality and life which are equally important. I'm a husband, a father, I have good friends, I'm involved in music, I'm involved in writing, I'm very active in social media, and these are all different parts of my life which aren't affected. But having said that, addiction was a very pivotal experience. And one thing it does make me is I'm full of gratitude that I did get a second chance, that people that cared for me did stick by me when I needed, that when I needed help, I met good people that were willing to help me. And it does make me appreciate the good things of life even more. It also made me a better doctor. My own frailty had been so starkly revealed that made me more understanding of frailty in others.
So for you, your main message from this is, yes, this is something that you won't ever completely get away from, but there is life after addiction. It's not, there is a way out. There is something else.
Yes, there is such a thing as redemption. You can get better. There is help. There are good people out there who will help you.
That was Liam Farrell, and if you or anyone you know has a problem and you'd like to talk to someone, Liam can be reached through his Twitter handle at Dr. L. Farrell.
Unfortunately, Liam's story is far from unique. It's very difficult to get exact statistics on addiction, but estimates from the National Drug Evidence Centre put it in the hundreds of thousands in the UK alone. So there's clearly something quite drastic going on in the brain here. And this is something Dr. David Belin from the University of Cambridge has been investigating for years.
So addiction is a state, it's a psychiatric disorder characterized by loss of control over habitual drug-seeking behavior in such a way that people continue searching for drugs and consuming drugs despite awareness of the negative consequences of doing so.
And which drugs do we think of when we think of addiction?
Often people tend to think about illegal drugs, such as cocaine, heroin, but actually alcohol and tobacco are heavily addictive as well.
And how have you been investigating this?
We are interested in understanding why only some individuals who are exposed to these drugs would eventually lose control over the consumption, because clearly there's an interaction between something in the brain before you start taking drugs and the effects of these drugs that would eventually make you vulnerable to addiction and you would develop the disorder. And we try to understand it using both clinical and preclinical approaches. And for this, we have the help of little rats that are very clever animals. And interestingly, as in humans, not all of them, if they're given access to drugs, would eventually develop addiction.
So let me get this right, Georgia. Not everyone forms addictions to these drugs.
No, in fact, rats, just like humans, have about a 20% chance of becoming addicted to cocaine.
So are they giving cocaine to the rats then?
Yeah, they did actually. They allowed them to have these small amounts they could take freely, but after a while, they started making them work harder and harder for their next dose. So they'd get them to press a lever once, twice, 10 times, 500 times. And after a certain point, most rats decide that, actually, the drug is not worth the effort. But 20%, the 20% that are addicted, keep pushing and pushing and pushing the lever up to 10,000 times to get their next hit.
They just can't stop, and they're sweaty. They put everything they've got into pressing this lever to get to the next fix. And these rats clearly are addicted.
Well, that's quite a powerful image there. Did you find out why some rats were more likely to get addicted than others?
We've identified a couple of behavioral traits, such as novelty-seeking and impulsivity, that predicted this vulnerability to switch from volitional to compulsive cocaine-seeking behavior. So impulsivity, for instance, is the example I tend to give my students all the time is during one of my lectures, if Chuck Norris is in the room and he stands up and say, I don't really like your lecture, and I actually engage a fight with him because I'm frustrated, this would be very impulsive because the consequences would be harmful and then I would regret it. So this is what impulsivity is. And we've actually identified this trait in cohorts of animals. 3 years after we made this discovery, the same vulnerability trait was identified in humans. So that was a kind of a success story.
Being more impulsive, novelty-seeking, those are traits identified that makes both rats and humans. You mentioned switch from an adaptive seeking of cocaine to a compulsive one. What is changing in the brain to make this change?
Initially, volitional drug seeking and taking behavior depends upon psychological mechanisms which require a pre-existing representation of the outcome. So when you and I work, and we work because we know, for instance, on Friday, we may go out to the pub, we have this representation of what we're going to do with the money we just earned. When the behavior becomes habitual, then the behavior is subjected to stimuli in the environment, and stimuli trigger specific behavioral features outside your awareness. So a good example in your everyday life is if you go back home tonight and it's dark, what are you going to do? You open your door and then you try to reach the switch and switch on the light. And what if in the morning before you left, the light bulb was broken? When you get back home, this is exactly what you would do. Nevertheless, you would try to switch on the light. And then you would say, oh, yes, it's broken. This is a habit. And this is exactly what drugs do. They hijack this system and they push the system towards drug seeking becoming habitual. So now every single time you are presented with a cue that you've experienced when you were taking drugs or seeking drugs, all these kind of cues are going to trigger a behavioral repertoire which actually has been designed so that you would get a drug. And you're not aware of what's going on. This is what a habit is. So there's a clear transition psychologically in what's going on.
So David's arguing that you're kind of going to autopilot, trying to get the next fix.
Yeah, exactly. And they've actually found evidence for this inside the brain. So when animals start taking drugs, there's loads of parts of the brain involved. One of these is the prefrontal cortex, which we really closely associate with decision-making and control. But what happens in addicts is after a few months, this system kind of changes and it switches to another area in the brain, which we associate with habit, but it completely circumnavigates the prefrontal cortex.
The area involved in control and decision-making.
Yeah, exactly. It forms this kind of back door in the brain, skipping past your kind of willpower centre, implying that it just doesn't come into it, which David argues means we should look at addiction in a very different way.
Addiction should be considered exactly as schizophrenia or diabetes. It's a chronic disorder and is not merely a question of willpower. If you suffer from it, then there's very little you can do yourself about it. And unfortunately, there are very few effective treatments for drug addiction. There's none for cocaine, for instance, for cocaine addiction. In terms of social implications, I think it is time to consider drug addicts really as patients and not as criminals. It's not because they want to harm anyone that they may actually go and steal their grandma to get some couple of quids to buy a line. It's because they have to because of their disorder. And as long as they aren't considered as patients, socially there would be something wrong with the way we handle drug addiction.
How does this finding correspond to actual therapies?
Yeah, this work does suggest some new drug candidates and treatment avenues to explore, but it's still very much a watch this space. But a huge thank you to Dr. David Vallon for speaking to me.
This is The Naked Scientists with Connie Orbach and Georgia Mills. Still to come, where does the evidence sit on drug policy? And how could illegal substances help in medical research?
And now it's on to the next in our series of Drugs 101, and it's time to explore ecstasy.
Since ecstasy's actual name is a bit of a mouthful, methylene dioxymethamphetamine, this drug goes by many street names, like E, MDMA, Adam, Mandy, X, or Molly. Ecstasy was first created just before the First World War as a base compound for other drugs. After being tested in the US Army, and even used as a therapeutic drug, ecstasy slowly rose to fame as one of the most popular party drugs of the 1980s. When a partygoer swallows the drug, it's rapidly absorbed in the gut and then converted to its active form in the liver. It then travels to the heart and is eventually pumped all the way to your brain. Upon reaching the central nervous system, it triggers a load of electrochemical firing and powers up some key chemicals, among them dopamine and serotonin. This change creates intense happiness, increased sociability and empathy, and an inability to sleep. These feelings generally last around 3 to 5 hours, as your brain naturally reabsorbs the serotonin and breaks it down. But because ecstasy releases so much serotonin, your body's response goes into overdrive, meaning that when the drug is worn off, there's less serotonin available to bind to the receptors and maintain a normal level of happiness. These low levels of serotonin bring on a short-lived period of depression for days after use, often called a come down. But depression is not the only side effect. Ecstasy can lead to other unpleasant sensations like irritability and tiredness, along with physical traits like nausea, jaw clenching, blurred vision, muscle cramping, and even a rise in body temperature. People who overdose on the drug may lose consciousness and have seizures, hallucinations, and even organ failure. But it's at its most dangerous when the drug is cut with other, cheaper substances like bleach somewhere along the production line, which can be fatal.
Now, Khalil mentioned some side effects there, but what's common in a lot of these drugs is that we really don't know what they do long term, especially as it's so hard to do clinical trials. So even if a drug doesn't seem that dangerous in the short term, it could still affect you further down the line.
We've already looked at the horror that can be caused by addiction, but that's not the only problem drugs can cause, both at a personal and societal level. Fatal overdoses, crime, long-term health problems and financial costs make drug policy a top priority in many countries.
In the Philippines, we've recently heard news that the president has announced a crackdown, encouraging suspected drug dealers to be killed on the spot. While at the same time, some states in America have just had marijuana made legal. Here in the UK, we actually have a class system, A, B and C, with A being classed as the most harmful with the harshest punishments, down to C as the least. But not everyone agrees it's the best system.
It's an emotive, controversial topic, this question of how to reduce drug harm. But what does the science actually say? Well, the Royal Society for Public Health, or RSPH, here in the UK just released a report calling for a change in how the war on drugs is fought. I spoke to Ed Morrow, campaigns officer at the RSPH.
The Taking a New Line on Drugs report is really the first time that sort of a major public health organisation in this country has come out with a strong line on how drugs policy in this country needs to undergo a major shift. Previously, we have been too focused on a criminal justice approach, which is just not working in terms of reducing harms from drugs. We've seen a situation over the past decades where, yes, although use of some of the less harmful drugs, such as cannabis, has continued to go down slightly, actually use of some of the most harmful substances, things like heroin, has risen slightly. And more importantly, the harm associated with those drugs, particularly the number of deaths associated with them, has risen significantly. So we are not tackling that harm coming from drugs. So what we've set out in this report is a new public health-based approach, which is focused on reducing the harm from drugs.
How would you go about doing this?
So one of the major pillars which underlies it is the idea of decriminalising possession and use of drugs. That is not the same as full legalisation, but we've been seeing for a long time that criminalising people who have a drug misuse problem does not help them get better. It puts a lot more costs onto society in the long run, and it also discourages people who have a drug misuse problem from coming forward for the treatment they need because they are scared of being prosecuted. So that's one of the first major steps we need to look at. And we also want to see much better, more universal drug education for young people.
Where does the scientific evidence for these arguments lie?
Well, we've been looking a lot at international examples of different countries that have tried similar approaches to what we are suggesting. One of the biggest examples we've been looking at is Portugal. Now, Portugal in 2001 decriminalised all possession and use of drugs in a similar way to what we would like to see. Now, over that period, they have seen a great increase in their health outcomes related to drugs. The number of deaths related to drug misuse has plummeted, I think, from around about 80 a year to around about 10 a year. Infection rates for various infections related to drug use, things like HIV and Hep C, those have also fallen through the floor. And at the same time, drug use has not risen in the way that some people have feared, and they still have a level of drug use which is well below the European average and is below what we have in this country.
Alcohol and tobacco, two of the most commonly used drugs in this country, and they're the two legal ones. Could this not be a warning that if we do move towards this decriminalisation, it might normalise the use of these drugs and maybe not immediately, but eventually lead to greater uptake.
If we again go back to the evidence of countries that have tried this approach, the example in Portugal, that is a 15-year scheme now where they've had this approach, and it has not seen a normalisation, has not seen an uptake in levels of use of other drugs. So we think what we've seen so far from other countries would disprove that fear.
And what about evidence from UK soil? Because I know drug use is very different from county to county, let alone between countries.
Well, it is interesting to look at the different ways in which police forces in this country are dealing with various types of drug use. So some police forces in certain parts of the country, Durham are one major example, have stopped actively pursuing and prosecuting people for possession and small-scale supply of cannabis. And, we have not seen the effect of usage going up in those areas. It's also interesting to look at the situation with what happened with cannabis being upgraded to a Class B drug in this country, which did not lead to a fall in use. So it very much seems, even with this country, that the level of enforcement, the level of penalties, does not have a direct link with the level of use. The resistance to making this change is not a scientific one, it's a political one, because the reality we live in at the moment is that drugs policy, both in this country and across the world, is driven by politics rather than the science, and that is a situation we need to change.
Recently, legal highs have just been banned in this country. Could you explain to me how this has been done and whether you think this is a good move?
Legal highs are or were substances which are designed to mimic the effects of traditional legal drugs, but with a slightly different chemical composition so that they would avoid the existing legislation and classification that would apply. The new Psychoactive Substances Act, which has come in to ban what were formerly known as legal highs, is an interesting situation. We think it's going to be quite problematic in terms of enforcement because it seeks to ban any new substance which has a psychoactive effect, and of course there are lots of perfectly innocuous substances which do have such an effect, and obviously they've had to put in exceptions for alcohol and tobacco and many sort of medicinal products as well.
I heard the original drafting accidentally banned things like paint and perfume and petrol.
Yeah, so it's that kind of thing. They've got themselves in a bit of a mess over this, but they've brought it in now. But the interesting thing as well for us on this is that what it has done is to ban production and sale of these substances, and it has not criminalised possession and use. So we think, even though this legislation is a bit of a mess in some ways, there is this inherent recognition from the government that criminalising people for drug use does not work. So we'd like to see that situation reflected with more traditional, if you like, illegal drugs.
That was Ed Morrow from the Royal Society for Public Health.
We asked the government for a response to the Royal Society for Public Health's report, and they gave us this statement.
This government has no intention of decriminalising drugs. The decriminalisation of drugs would not eliminate the crime committed by the illicit trade, nor would it address the harms associated with drug dependence and the misery that this can cause to families and communities. The UK's approach on drugs remains clear. We must prevent drug use in our communities and support people dependent on drugs through treatment and recovery. At the same time, we have to stop the supply of illegal drugs and tackle the organised crime behind the drugs trade. There has been a reduction in drug misuse among adults and young people compared with a decade ago, and more people are recovering from dependency now than in 2009 and 2010.
We'd love to hear everyone's thoughts on this, so please do get in touch with us. You can tweet us at Naked Scientists, or if 140 characters won't cut it, then join in the debate on our forum, which is at nakedscientist.com/forum.
Hello, Greya here from Naked Astronomy. I wanted to say hey and tell you about my new podcast. It's an awesome audio adventure into the big black cosmos that we inhabit. What's out there? How did it all begin? And what will happen in the end? Presented and produced by yours truly. You can find it on most podcasting platforms. Just search Naked Astronomy.
You're listening to The Naked Scientists. I'm Connie Orbeck, and with me is Georgia Mills, and this week it's all about the science behind drugs. Next, we'll be finding out if drugs can be used to help instead of hinder. But first up, let's get the lowdown on LSD, aka acid.
Think of LSD and you probably think about the Beatles' iconic movies of merging colours and floating submarines, or the flower power and heady stories of 1960s San Francisco. Acid has been a controversial inspiration to many great thinkers, from Aldous Huxley to Steve Jobs. But what's happening in the brain to give such life-altering experiences? The hallucinogen LSD, or lysergic acid diethylene, was brewed almost 100 years ago in Switzerland, and like many scientific discoveries, was a bit of an accident. In fact, Albert Hofmann had no way of knowing that his new drug, which was meant to stimulate blood circulation and breathing, would have such a strong psychedelic effect from just the smallest of doses. After accidentally touching a tiny crystal to his tongue, he experienced firsthand the effects of his powerful hallucinogenic drug. Time slowed down, and he later described an uninterrupted stream of fantastic pictures, extraordinary shapes with intense kaleidoscope-like play of colours. For the next couple of decades, LSD led a glamorous existence, as it was experimented with in science, music, literature, and even used in mind control experiments by the CIA, before it was made illegal in the late 1960s. When a person takes LSD, part of it is metabolized in the liver and eventually excreted. The other part quickly gets to work changing things inside the brain. It's believed that LSD interferes with serotonin, a chemical messenger that has a big role in mood, emotion, and sleep patterns. Through acting on specific receptors, the drug appears to break down barriers that usually separate areas of the brain from each other, allowing vision, movement, and hearing to all blur together, causing hallucinations and free flow of thought, often referred to as a trip. One symptom, known as ego dissolution, arises as the cells in our brain, our neurons, fail to fire together, stopping the brain from functioning in a coordinated manner. This can dissolve a person's sense of self, as their own thoughts are united with the environment, resembling the brain of an infant, free and unconstrained. But no two LSD experiences are the same, and while the idea of a communion with nature may sound tempting, it's hard to predict which way a trip will go. With one dose lasting up to 20 hours, and many people reporting repeat trips years later, heaven can sometimes turn hellish.
So far, we've looked at our historical use of drugs, the harm they can do, and how addiction hijacks the brain. But what about the possible good that could come from these substances?
Research into medical uses for certain illegal drugs has been picking up pace in the past few years. But there are still a number of barriers, meaning that globally, the amount of work in this area is minimal. George Greer is the medical director of the Hefter Research Institute in the United States, and he explained to me why psychedelic drug research is such an underfunded area.
Well, there's a couple of problems. One is these drugs cannot be patented, so there's no commercial interest or investment. So the drugs are out of, too late to get a patent. Governments, with the exception of UK, have been reluctant to fund this research, and we can all speculate why, but I assume because they're Schedule I abused is part of the mindset. So that's really the biggest limiting, is the lack of government funding, which means the lack of researchers who can expect to be funded for a career. So they have to do other research for their career path that has more stable funding. And then being in Schedule I does create more expense by having to go through more hoops because of with the drug enforcement agencies, which require security and paperwork and that sort of thing. So that's an inhibition too, and just the stigma of people think these drugs are bad. So there's a lot to overcome.
Schedule I is a class of drug that is deemed to have high abuse potential and no medical use. Drugs that sit in this category vary from country to country, but in the USA, they're things like heroin, LSD, marijuana, MDMA, and a whole host of other obscure things. But by putting these substances into Schedule I, a sort of catch-22 is created. Drugs that have no medical use are under harsher restrictions, making them harder to research, therefore making it more difficult to determine any medical use for them. This has stifled research for a long time, but luckily, things are changing.
An opportunity arose beginning in the early 90s to do research investigations in normal volunteers. That was the first opening. I had the second permitted study, which was with MDMA at Harbor UCLA Medical Center. Once we established the feasibility, our group and other groups were able in the early 2000s to obtain regulatory approvals to conduct clinical research in a population that was presenting because of a particular psychiatric condition.
That's Charles Grobe from UCLA, and despite the difficulties, he's been researching possible medical uses for Section 1 drugs for years. One particular study, funded by Hefter of course, examined the potential of psilocybin, that's the thing that makes magic mushrooms so magical, to treat extreme anxiety in cancer patients.
They were provided a number of screening and also preparatory psychotherapy sessions. They came in for 2 separate treatment sessions. One session was active medicine, psilocybin. Another session was placebo. We sat with them for the entire 6 to 8 hour psilocybin experience, and afterward we did some rather intensive integrative psychotherapy sessions to help them assimilate their experiences. And then we followed them for the next 6 months, just examining their anxiety, their mood, other aspects of their quality of life. And we found very good results. We found that over time there was a significant improvement in levels of anxiety at particular points in time. And having gotten to know many of these subjects quite well, we also observed that there were clear and distinct improvements in their quality of life in the time they had remaining.
But you're now working on actually not a hallucinogenic, but MDMA or ecstasy.
Yeah, MDMA is related to hallucinogens, but with clearly distinctive differences, and is really in a different class altogether. We've had a study going for the past 2 years where we've had permission to treat a population of autistic adults who have severe and often incapacitating social anxiety with an MDMA treatment model. We haven't quite finished the study. We're still looking to recruit 2 final subjects, so we haven't done our final data analysis, but just having gotten to know our subjects very well and having really been in the room for all of the treatments, it's my impression that we will observe some positive results, that this treatment model may have merit when utilized under optimally safe conditions.
So it sounds like what we're talking about with both the psilocybin and also this one is real changes in quality of life.
Yes, absolutely. A clear observation in all of the studies done with psilocybin and MDMA over the last 12 to 15 years.
So clearly things are moving on, but it does make me think. I mean, this all sounds a bit of a faff, really. How feasible is it really to give controlled substances to people? Here's George again.
Psilocybin, it's never going to be a drug that a person is sent home with a prescription or sent home with capsules of psilocybin, because they always have to use it with supervision. So in terms of distribution, it's only going to go to the clinics who are administering the drug. It's a big procedure, that takes many meetings. None of that is because it's a Schedule I drug. That's all because of just the effects of the drug.
But still, either way, any drug which requires this amount of supervision seems a little unfeasible.
Yeah, but the benefits we're seeing, this 1 or 2 sessions, can last for weeks or months, as opposed to taking a drug every day.
I guess my other question is, if it's so difficult to study these things, there's so little funding for researchers, there's a lot of work that they have to go through, why aren't we focusing our attention on maybe pre-existing drugs for anxiety, which aren't within this kind of Section 1 area?
Drug companies are doing that all the time. They're researching and looking for new drugs that are similar to the ones that we have on the market now. And psilocybin, because it works in a different way, it has an effect that the current drugs or drugs like them are not going to have, because they all require daily use.
So given all this, given that these drugs act in a different way that isn't actually available on the market, Does it make you sad that we've potentially been sitting on these drugs for a long time and not used them as early as we could when maybe we knew that they could be effective?
Well, sure. I mean, I think those of us in the field have gone through that grief process a long time ago of the loss of these decades that people could have been helped and much more could have been learned. And we're focused on going forward and doing the research, which is being done now. And private people are coming forward to pay for it. So I think the mood among the research community is very positive, though recognizing soberly that there are going to be frustrations and difficulties and stops and starts. But I think we're all feeling very optimistic. This is really going to start benefiting people in the next several years, certainly by 10 years. I think Europe, the US, and UK these will be available treatments for people.
George Greer from the Hefter Research Institute, and before him, UCLA's Charles Grobe. Thanks to the University of California in Irvine for kindly lending us their studio for that one.
And that unfortunately brings us to the end of the programme. And it feels like we've kind of barely scratched the surface here.
I know, we've covered so much, but I'm still so confused. I feel like clearly drugs can be abused and everyone wants the same thing in the end, right?
Reducing the harm these drugs can cause.
Yeah, no one's pushing to have everyone hooked on drugs. But equally, how we're going to go about doing that seems still really contested. And when I think about this idea that drugs have been with us since the very beginning, since before we were human, seems like maybe we have too much of a relationship with them for some sort of outright ban.
I know, and I'm sure a lot of people listening to this are drinking tea or coffee or maybe a glass of wine. They're still very much a part of our culture, legal or otherwise.
But then when you think about Liam Farrell, what I found so interesting was him talking about drugs having control. And then your interview with David Bennon, he says that we really need to rethink the way we think about drugs. And I think addicts know that, but society doesn't. And it's so easy to blame the addict.
And any drug, even the ones we don't think of as addictive, you take them one time and they do change your brain, perhaps permanently. And there's still so much we don't know. And like you said in your interview, researching them is hard to do, whether that's for medical uses or just in terms of what happens long term with these drugs. So there's still so many questions we need to answer.
Absolutely. And I think if making this programme has taught me anything, it's that whether in research or policy or, I don't know, welfare, science really needs to have a place in the debate.
Let's hope it does then. And a huge thank you to everyone who's been listening and to all our guests. Special thanks go to Luchka Bibic and Nottingham University's Khalil Thurloway for helping us out with production. Do join us next week because we'll be putting pen to paper for the science of animation. The Naked Scientist comes to you from Cambridge University and is supported by the STFC, the EPSRC and Rolls-Royce. I'm Georgia Mills and thank you for listening. Goodbye.